watching Nama channel.
Now we see exercise 2.3. Divide the polynomial p of x by the polynomial g of x and find the quotient and remainder in each of the following. First question, p of x equal to x cube minus 3x square plus 5x minus 3 and g of x equal to x square minus 2. Here there is no x term, so we take 0 for that. Normal division. X cube minus 3x square plus 5x minus 3. Here x cube and then x square, x and 3. All the degrees, all the variables is there. Here x square, there is no x term. Because of that I put 0 minus 2. So now we compare the first term. X cube divided by x square, we get x. The first multiple is x. So x into x square, x cube, x into 0 plus 0, x into minus 2, minus 2x. Now as usual method we have to change the symbol. Minus, minus, plus. So different symbol, it will cancel. Minus 3x square, minus 3x square, plus 5x and then plus 2x, we get plus 7x and take another term minus 3. Again we compare the first term. Minus 3x square can be divisible by x square, x square will get cancelled, minus 3. So we multiply with minus 3, minus into plus, minus 3x square and then 3 into 0, 0, minus into minus, plus 6. So again we change the symbol. This one become plus and then minus, here become minus. So it will cancel. So our answer 7x minus 9. Therefore, quotient and remainder for this p of x can be divisible by g of x. So q of x is the quotient, x minus 3 is the quotient, and then remainder r of x equal to 7x minus 9. Next we move on to second. Now we see question number 2. Solution. Here x power 4 is there. Here x power 3 is not there. Because of that, p of x equal to x power 4 plus 0 x power 3 minus 3x square plus 4x plus 5. And then g of x written in the form x square minus x plus 1. So now as usual dividing method. X power 4 plus 0 x cube minus 3x square plus 4x plus 5. This one can be divisible by x square minus x plus 1. We compare the first term, x power 4 divided by x square. So we get x square. So x square into x square, x power 4. And then x square into x minus x cube. Plus into minus, plus into plus, plus x square. Now we change the symbol. Plus 1 become minus, minus 1 become plus, again plus 1 become minus. Here same variable with a different symbol, it will cancel. We get plus x cube. And then minus 1, minus 3, we get minus 4 x square. And we take the third term plus 4x. Now we compare the first term. X cube divided by x square, we get x plus x. So x square into x, 2 plus 1, 3. So x power 3. And then minus into plus, minus x square, plus into plus, plus x. Again plus 1 become minus, minus become plus, and then plus 1 become minus. Same variable with a different symbol will cancel. Minus 4x square plus 1x square, we get minus 3x square. And then plus 3x, the third term, plus 5. Again we compare the first term. Minus 3x square divided by x square. X square we can minus 3. So plus into minus, minus 3 x square, minus into minus, plus 3x, plus into minus, minus 3. Now we change the symbol. Minus 1 become plus, plus 1 become minus, minus 1 become plus. Here minus 3x square plus 3x square cancel, plus 3x and then minus 3x cancel, plus 5 plus 3 we get 8. Therefore p of x can be divisible by g of x. We get quotient q of x equal to x square plus x minus 3 and then r of x remainder which is equal to 8. Next we move on to Roman letter 2. Now we see Roman letter 2. Check whether the first polynomial is the factor of second polynomial by dividing second polynomial by the first polynomial. So we have to divide this second polynomial by first polynomial. We get the remainder is 0. We conclude first polynomial t square minus 3 is the factor of second polynomial. Otherwise this one is not a factor for second one. So directly move on to division. So 2t power 4 plus 3t power 3 minus 2t square minus 90 minus 12. Here t power 2, there is no t power 1. So because of that I will put 0 minus 3. So first we compare as usual. 2t power 4 divided by t square, the remaining 2. So we get 2t square. So 2t square can be multiple with 2 into 1, 2, t power 2 into t power 2, t power 4. So it becomes plus 0. And then plus into minus, minus 6t square. Now we change the symbol. Minus, minus, plus. So first one become cancel. Here we get plus 3t power 3 plus 6t minus 2t. So plus 6 minus 2 we get plus 4t square. We take minus 90. As usual we compare the first term. So 3t cube divided by t square. We get remaining 1. So 3t. So plus into plus, plus 3 into 1, 3t power 3. So second one becomes 0 and then plus into minus, minus 9t. Now we change the symbol. Minus, minus, plus. So here we get this one become cancel. Here 4t square and then plus 90 and then minus 90. This one becomes 0. We take third one. Minus 12. So 0 minus 12. So 4t square can be divisible by t square. We get 4 plus 4. 4 into t square, 4t square plus 0 minus 12. Now we change the symbol. Plus 1 become minus, plus 1 become minus, minus 1 become. So plus minus 40 square is 0 and then automatically 0 minus 12 plus 12. So whole term we get 0. So r of x equal to 0. So we conclude we get the remainder 0. Because of that we conclude the first polynomial is the factor of second polynomial. Therefore t square minus 3 is factor of 2t power 4 plus 3t cube minus 2t square minus 9t minus 12. So as usual the same method. You have to do it as a homework remaining. Second one and third one as do it as your homework. Now we see question number 3. Obtain all the zeros of 3x power 4 plus 6x cube minus 2x square minus 10x minus 5. If two of its zeros are square root 5 by 3 minus root of 5 by 3. So this question is equal to question number example 9. So because of that, since zeros of polynomial 3x power 4 plus 6x cube minus 2x square minus 10x minus 5 are root 5 by 3 comma minus root 5 by 3. Therefore, x plus square root of 5 by 3, x minus root of 5 by 3 are factor for polynomial p of x, for polynomial p of x, which implies that x plus root of 5 by 3 into x minus root of 5 by 3. It can be written in the a plus b, a minus b, written in the form a square minus root 5 by 3 the whole square. So x square minus 5 by 3. So we take it as g of x. Now normal division method, we have to divide the p of x by g of x. So g of x equal to x square minus 5 by 3. So now we have divide p of x by g of x. As usual method, we have to divide it to find the remaining zeros of the polynomial. So here p of x equal to 3x power 4 plus 6x cube minus 2x square minus 10x p of x equal to 3x power 4 plus 6x cube minus 2x square minus 10x minus 5, and then g of x equal to x square minus 5 by 3. So now we divide 3x power 4 plus 6x cube minus 2x square minus 10x minus 5. Normal division method. X square minus 5 by 3. So first we have to compare first term. 3x power 4 divided by x square. So we get 3x square. We multiply with 3x square. So 3 into 1, 3x power 4. So here there is no x term. Because of that,
Thank you for watching நம்ம சேனல். இந்த வீடியோ உங்களுக்கு பிடிச்சிருந்ததுன்னா லைக் பண்ணுங்க, கமெண்ட் பண்ணுங்க, ஷேர் பண்ணுங்க. வீடியோ அடிக்கடி பார்க்கிறதுக்காக இந்த சேனலை சப்ஸ்கிரைப் பண்ணிட்டு மறக்காம பக்கத்துல இருக்கக்கூடிய பெல் ஐகானை ட்ரைன் தட்டுங்க.
So here 3 cancel, we get minus 5 x square is in the form x square term. So we substitute minus 5 x square here. There is no term for x cube. We put 0. So as usual method, we have to change the symbol minus, minus, and then plus. Here this one become cancel. So 6x cube, we take it as 6x cube plus 5x square minus 2x square plus 3x square, and we take minus 10x. So as usual, we compare the first term. 6x cube can be divisible by x square. We get 6x plus 6x. So 6 into 1, 6, x square into x, x cube. So next we have to multiply minus 5 by 3 into 6x. 1 3 is 3, 2 3s are 6. So minus 10x. Here x term is there. So we compare minus 10x. there is no term for x square, so I will put 0. So plus 1 become minus, again plus 1 become minus, here minus 1 become plus. 6x cube minus 6x cube cancel, minus 10x plus 10x cancel. We have 3x square and then another term minus 5. So as usual, again the same method we repeated. 3x square can be divisible by x square, we cancel, we have 3. So plus 3. So 3 into x square, 3x square, as usual minus 5 by 3 into 3, we get minus 5. Minus 5. Now we change, plus 1 become minus, minus 1 become plus, so all the term will get 0. Now we have the coefficient 3x square plus 6x plus 3. So here the quotient is in the form of quadratic polynomial. So we are to using splitting method to find the remaining two zeros of the polynomial p of x. So I take that quotient quadratic polynomial. By as usual splitting method, I have to find the factors and zeros, remaining two zeros for the polynomial p of x. So 3x square plus 6x plus 3. So here our target is 3 into 3, 9 and then plus 3. So factor for 3 is 3 into 3 equal to 9. And then next 6, 3 plus 3 which is equal to 6. So we reach the target. So 3x square plus 6x plus 3. This 6x can be split out. 3x square plus 3x plus 3x plus 3. So I will take the first two and then second two. First two, the common term is 3x. So the remaining term x plus 1. And then here we take it out 3. So x plus 1. Which is equal to 3x plus 3 and then x plus 1 is the factor for 3x square plus 6x plus 3. So which implies that 3x plus 3 into x plus 1 equal to 0, 3x plus 3 equal to 0, 3x equal to minus 3 and then x equal to minus 3 by 3 equal to minus 1. Then x plus 1 equal to 0, x equal to minus 1. So already we have a two zeros of the polynomial p of x 3x power 4 plus 6x cube minus 2x square minus 10x minus 5 is root 5 by 3 and minus root 5 by 3. So and we have to find any more two zeros, minus 1 and minus 1. Therefore all the zeros of polynomial p of x are. So first we have root 5 by 3, comma minus root 5 by 3, comma minus 1 and minus 1. So these are the zeros of the polynomial 3x power 4 plus 6x cube minus 2x square minus 10x minus 5. So this one is not a different method. So already they already given the zeros. We take it x plus 5 root 5 by 3 and x minus root 5 by 3 is a factor for the polynomial. That one can be changed as x square minus 5 by 3. As usual we have to divide in the normal method p of x by g of x. We get the quotient as a quadratic polynomial. By using splitting method we have to find the factor, that is 3x plus 3 and x plus 1. So that is the zeros of the polynomial 3x square plus 6x plus 3. So we get x equal to minus 1, x equal to minus 1. So finally we got 1, 2, 3, 4 zeros of the polynomial p of x.